We can apply that same concept from simplifying radicals with numbers to simplifying radicals with variables. Except in this case, we can actually use a little trick. Well, we know the square root of x squared is just going to be x. But why is that? Well, that's because x squared is the same thing as x times x. And if we find a pair, well, that's going to make just x outside of the square root. This kind of trick that we can use is we can take whatever number is inside the radicand and divide it by the number outside the radicand. So in this case, 3 divided by 2 is 1. We know there's going to be 1x outside, or x to the first on the outside. 3 doesn't divide evenly by 2, though. There's 1 left over. So we also know there will be 1x inside of the square root. So for the next one, for example, if we did 4 divided by 2, well, 4 divided by 2, that works out evenly. There's nothing left over. So we know it'll just be x squared. And again, to think about why that's the case, x squared times x squared, that makes x to the fourth. There's a pair of x squared, so that comes outside of the square root. In the last one here, if we had x to the fifth divided by 2, well, how many times does that go in? It goes in twice. So there's going to be 2 x's, or x squared, on the outside. What's left over on the inside? Well, 5 divided by 2 is 2 with 1 left over. So our final answer would be x squared times the square root of x. Just like we were able to reduce with just numbers, we can also reduce with numbers and variables. So again, some things to think about are always looking for the largest perfect squares, and for variables that we can divide by 2 as a kind of shortcut. So take a second and try numbers 1 through 5 on your own, and then unpause the video and check to see if you got them correct. All right, so for number 1, if you found there's a couple ways to get there, but if you used prime factorization, you'd find there were 2 pairs of 2. If you did the largest square root, you would have noticed that 16 times 7 multiplies to get 112. So we can pull out either way 4. 4 times the square root of 7 is a simplified version of a square root of 112. There's already a negative 5 on the outside, so we'll have negative 5 times 4, giving us a final answer of negative 20 square root of 7. Continuing on, taking a look at number 2. If you use the largest square root method, the largest square root that goes into 48 is the square root of 16. Square root of 16 times 3 times the square root of 3. N squared divides evenly, so n squared divided by 2 is just 1n on the outside. The square root of 16 becomes 4, so our final answer is 4n, and then left over on the inside is we have the square root of 3. There's a number of ways to do each of these problems, so I'm going to share the correct answers for now. Please come into class tomorrow if you have any questions. So for number 3, n to the 7th divides by 2 3 times with 1 left over. The square root of 60 can break down into the square root of 4 times the square root of 15. So 2m to the 3rd square root of 15m. For number 4, if you break down the square root of 150, the largest square root is 25. 25 times 6. So that will simplify to 5 square root of 6. X to the 5th divides twice by x, leaving x squared and 1x on the inside of the square root. There was already an x on the outside at the beginning, so that's how we end up with x to the 3rd, with 5 on the outside and 1x left over on the inside with the square root of 6. For number 5, the correct final answer is negative 4b squared square root of 34. For number 6, 7, 8, 9, we're going to start to see multiplying square roots. So there's a number of ways to do this. You can think about the square root of 30 as not really an even perfect square, but if we multiply 6 times 30, it will be 180. So we can always multiply together to get a larger square root and then break it down. That's helpful because the square root of 36 times the square root of 5 does get to 180. So if we multiply these together, now we can pull that square root of 6 out to end up with 6 square root of 5. Same thing for number 7. So if we multiply together the square root of 3 times the square root of 96, we'll end up with 2 square root of 288. And then we can break that down. Well, 288 divides pretty simply by 144 twice. The square root of 144 is 12, so then we have 2 times that 12, giving us 24 square root of 2. Why don't you try and put that same process into action for number 8 and number 9, and then unpause and see if you did it correctly. So hopefully for number 8, you multiplied together to get 48, and now we have a to the 6th, because a to the 1st times a to the 5th is a to the 6th. If we then break down that square root, 16 and 3, we'll end up with 4a to the 3rd square root of 3. A to the 6th divides by 2 to get to a to the 3rd. So 136 divides by the square root of 4 times the square root of 34. So that we'll end up with negative 4b square root of 34. All right, as a little challenge, please try the real-life application problem on your own. And one hint for you is that if you redraw the triangle like that, we'll have w, 3w, and if you don't remember from 7th grade, the Pythagorean theorem is a squared plus b squared equals c squared. All right, so for today, you should feel good on how to simplify and multiply together square roots. Tomorrow, we'll take a look at how to deal with denominators and how to use the division property of square roots. Please make sure you're prepared for our Regents Review quiz tomorrow as well.